Next one is geometry. Now, the English word geometry can be derived from two Greek words. The first one is geo and the second one is metria. The English word geometry can be taken from two Greek words. The first one is geo and the second one is metria. Geo means an earth. Geo means an earth. Metria means measurement. So, geometry means measurement of an earth. So, first of all, the English word geometry can be taken from or geometry derived from two Greek words. The first one is geo and the second one is metria. Geo means an earth. Metria means measurement. So, geometry means measurement of an earth. Right. So, this is the first one. Now, the second concept. The father of geometry. The father of geometry. Who is the father of geometry? Father of geometry is Euclid. He belongs to before Christ 3rd century. Before Christ 3rd century. And he is Greek scientist. He is Greek scientist. So, the father of geometry is Euclid. So, he is a Greek scientist and before Christ 3rd century. But actually, Euclid born at Alexandria town, that is in Egypt. But he settled at Greek. So, the father of geometry Euclid belongs to, the father of geometry Euclid belongs to Greek country only. Actually, he born at Egypt in Alexandria town. But he settled at Greek. So, we conclude that Euclid belongs to Greek country only. Okay, right. Now, the third point. Who proposed geometry? Who proposed? So, the father of geometry Euclid. So, he proposed geometry in logical order. He proposed geometry in logical order. So, the very first question is, who proposed geometry in logical order? He is nothing but Euclid. And he is the first person to use geometry in experimental way. So, and the second question is, who proposed geometry in logical order means he is Euclid. Who is the first person to use geometry in experimental way? He is also Euclid. And he wrote a book, that is the Elements. So, the book Elements is written by whom? That is also Euclid. Who is father of geometry? He is also Euclid. Who proposed geometry in logical order? He is also Euclid. Who is the first person to use geometry in experimental way? He is also Euclid. So, we have 4 bits on this concept. The very first one is, who is the father of geometry? And the second one is, who proposed geometry in logical order? And the third question is, who is the first person to use geometry in experimental way? And the fourth question is, the book Elements is written by whom? So, these 4 questions contain same answer and it is Euclid. Right? Once again, so geometry. What is geometry? So, the English word geometry can be derived from 2 Greek words. The first one is geo and the second one is metria. Geo means an earth. Metria means measurement. So, simply says geometry means measurement of an earth. That is the first one. And the second concept is, who is father of geometry? Who is father of geometry? He is Euclid. He belongs to Greek country. He is Greek scientist and also belongs to 3rd century before Christ. But actually, Euclid born at Alexandria town, that is in Egypt. But later, he settled at Greek. Hence, we treated Euclid is a Greek scientist only. Right? Next. Who proposed geometry in logical order? He is also Euclid. Who is the first person to use geometry in experimental way? He is also Euclid. The book Elements is written by whom? That is also Euclid. Okay, right. Now, so the Elements is the group of 13 books. 13 volumes or 13 books. So, the book Elements is the group of 13 volumes. In 13 volumes, 1 to 6 and 11 to 13. These books denotes about geometry. About geometry. So, rest of the books 10 to 13. These books represents, right. So, in these 13 books, 1 to 6 and 11 to 13 represents or denotes about geometry, and the rest of the books 7 to 10 about numbers. About numbers. Right. So, this is the second concept. So, third concept. Now, the construction of geometry, or to construct the geometry, there are a few main stages are there. So, construction of geometry depends on below stages. Construction of geometry, or the construction of geometry depends on few main stages. The main stages are the first one is undefined words. Undefined words. And the second one is defined words. And the second one is defined words. And the third one is theorems. And the third one is theorems. And the last one is axioms. Last one is axioms. So, to construct the geometry, there are a few main stages are there. To construct the geometry, there are a few main stages are there. The main stages are the first one, undefined words. And the second one is defined words. And the third one is theorems. And the last one is axioms. So, what are the undefined words in our geometry? In our geometry, undefined words are the first one, point. Second one, straight line, or simply says line. And the third one is plane. And the last one is space. In our geometry, these all are the undefined words. So, the undefined words in our geometry is point, line, plane and space. Except these terms, remaining terms all are defined words. Except these four, remaining all words are defined words. And the third one, theorem. So, what is meant by theorem? What is meant by theorem? What is theorem? The statements which can be well defined. The statements which can be well defined are known as theorems. So, theorems means the statements which can be well defined or known as theorems. Right. So, to construction of geometry depends on these four things. Or to construct the geometry, there are a few main stages are there. The first one is undefined words. Second one is defined words. Third one is theorems. Fourth one is axioms. Now, what is the definition of the theorem? Theorem means the statements which can be well defined are known as theorems. Now, every theorem is of the form P if Q. Every theorem is of the form P if Q. Right? That means every theorem has how many parts? 2 parts. Every theorem has how many parts? 2 parts. What are the 2 parts? Part of the statement before if, that means P. What is the second part? Part of the statement after if. So part of the statement before if, that means P, is known as hypothesis or data. The part of the statement after if is known as abstract or summary, or simply says conclusion, right? So the theorem. What is theorem? What is meant by theorem? The statements which can be well defined are known as theorems. Now every theorem is of the form P if Q. Hence every theorem has 2 parts. What are the 2 parts? Before if, after if. The part of the statement before if, the part of the statement before if is known as hypothesis or simply says data. At the same time, the part of the statement after if, is known as abstract or summary. Right. So, what are the undefined words in our geometry? The undefined words in our geometry are, the first one is point, and the second one is line, and the third one is plane, and the last one is space. Except these 4 things, these 4 terms, remaining all terms are in our geometry or defined words. Now third one, theorem. Theorem means the statements which can be well defined. The statements which can be well defined are known as theorems. Actually, every theorem is of the form P if Q. So, every theorem has P if Q means every theorem has 2 parts. The first part is P and the second part is Q. What is P? Part of the statement before if. That is named as hypothesis or simply data. Now the second part Q. What is second part Q? Part of the statement after if. So that is known as abstract or summary. Right. So next one. The various stages in the structure of the geometry. So the various stages in the structure of the geometry. So about geometry, construction of geometry depends on 4 stages. Now here the various stages in the structure of a theorem. The various stages in the structure of the theorem. The first one is general information. And the second one is figure. And the third one is hypothesis or data. And the fourth one is conclusion, abstract or summary. And the fifth one is construction. And the last one is proof. So before of this one, we learnt about 4 stages. Those 4 stages denotes about the construction of geometry depends on the 4 stages. The 4 stages are, first one undefined words, defined words, theorems, and the last one is axioms. But here 6 stages. These 6 stages about theorem. The various stages in the structure of a theorem means the first one is general information, second one is figure, third one is data, fourth one is summary, fifth one is construction, and the last one is proof. So In previous DSC you have a bit. So that is, which of the following step, which of the following step may not be required in the proof of all theorems. So which of the following step may not be required in the proof of all theorems? So the given options are, first one figure, second one data, third one summary, and the fourth one construction. So which of the following step? Already we have 4 steps are there to prove the various stages in the structure of geometry means general information, figure, data, summary, construction, and the last one is proof. But here the question is, which of the following step, in these 6 steps, which of the following need not be necessary? That means which of the following step may not be required in the proof of all theorems. That means the word, the step used in some theorems only. Some theorems that word cannot be used. So what is that one? So when the theorem is given, the proof of the theorem, when we prove the theorem, first of all we will draw the diagram. So this is necessary. When the theorem is given, data is also there. When theorem is given, then summary is also there. But some theorems can be solved without construction. So which step may not be required in the proof of all theorems means that is nothing but construction. So this is not used in all theorems. Some theorems we cannot build a construction. So some theorems need not be necessary. So which of the following step may not be required in the proof of all theorems means that is nothing but construction. Right, once again from the beginning. So the English word geometry can be taken from 2 Greek words. Right. Now the English word geometry can be taken from 2 Greek words. The first one is geo and the second one is metria. So what is meant by geo? Geo means an earth. What is meant by metria? Metria means measurement. So simply the meaning of geometry means measurement of an earth. So that is the first one. Now the second one is, who is father of geometry? Who is father of geometry? He is Euclid. He is a Greek scientist and he is 3rd century before Christ, 3rd century. He is a Greek scientist born in before Christ, 3rd century. So exactly 325 to 265, 223 to So the father of geometry, Euclid. He is a Greek scientist and before Christ, 3rd century. Now, who proposed geometry? Euclid. He is the person to use geometry in logical order. Euclid is the first person to use geometry in experimental way. He proposed geometry in logical order. He proposed geometry in experimental way. Euclid wrote the Elements, or the book Elements is written by Euclid. The Elements is the group of how many books? 13 books. 13 volumes or 13 books. In these 13 volumes, only 1 to 6 and 11 to 13 denotes about geometry. Rest of the book 7 to 10 denotes or represents about numbers or number system. So we have a bit on old papers. So that is, who proposed which country? Which country proposed geometry in logical order? Which country proposed geometry in logical order? So who is the father of geometry? Euclid. He belongs to which country? Greek country. So which country proposed geometry in logical order means that is nothing but Greek country. So which country proposed geometry in logical order means that is nothing but Greek country. So this is the second point. And the third concept. What is third concept? To construct this geometry, there are a few main stages are there. The first one is undefined words, and the second one is defined words, and the third one is theorems, and the last one is axioms. So what are the undefined words in our geometry? In our geometry, the undefined words are mainly says the first one is point, and the second one is line, and the third one is plane, and the last one is space. So these four are the undefined words in our geometry. So except these four words, remaining all words are defined words in our geometry. Now third one, theorem. So what is meant by theorem? Theorem means the statement which can be well defined, or the statements which can be well defined are known as theorems. Actually, every theorem is of the form P if Q. So first part P, second part Q. So every theorem has how many parts means every theorem has two parts. The first part is part of the statement before if. That is P. Now P is, what is P? That is the part of the statement before if, known as hypothesis or data. And the second part is Q. What is Q? That is the part of the statement after if. That is known as abstract or conclusion, or simply says summary. Now, so already we learnt about the construction of geometry depends on the four stages. Here the structure of a theorem. Here the structure of a theorem depends on 6 stages. Before of this one, construction of the geometry depends on 4 stages. But here the structure of geometry depends on 6 stages. The first one is general information, and the second one is diagram, figure, and the third one is hypothesis or data, and the fourth one is summary, and the fifth one is construction, and the last one is proof. Okay. Now here we have a bit in previous papers. So that is, which of the following step may not be required in the proof of all theorems? So any option is given, we will choose construction. So construction is the step may not be required in the proof of all theorems. So that is required in some proofs only, but not all proofs. So which of the following step may not be required in the proof of all theorems means any options are given, we choose construction only. Axioms. Already before of this one we learnt about theorems. Theorems means the statements which can be well defined. We define well defined. But here axioms. Axioms means the statements considered as true. The statements considered as true but not well defined. That means the statements considered as true but not able to prove. In the theorems there is able to prove, here not able to prove. There is well defined, here not defined. So axioms means the statements which can be, the statements which can be considered as true. The statements which can be considered as true but not able to prove. But not able to prove. In every theorem is able to prove, but axiom not able to prove, but that can be treated as true. So the statements which can be considered as true simply says the statements considered as true but not able to prove is known as axiom. Now in the next one, this is the fifth one and the sixth one. Euclid axioms are dash. Euclid axioms. There are 5 axioms are there. Euclid axioms are, how many axioms are there? 5 axioms are there. So Euclid axioms are 5. In these 5, what is the first one? A unique line passing through 2 distinct points in a plane. What is the Euclid's first axiom? If you take any 2 points, then a unique line passing through these 2 distinct points in a plane. So that is the Euclid's first axiom. So Euclid's first axiom is, we can draw a unique line. We can draw on a unique line passing through two distinct points in a plane. So this is the Euclid's first axiom. So actually axioms means the statements which can be considered as true but not able to prove. So the type of statements are known as axioms. Here Euclid axioms are, how many axioms are there? So Euclid axioms are 5. In these 5 axioms, the first one is, we can draw a unique line. Line means straight line. A unique straight line passing through 2 distinct points. We take any 2 distinct points in the plane, then we draw only one straight line passing through those 2 points. So that is the first axiom. And the second axiom. Now take a line segment AB. So this is line segment AB. A line segment has 2 endpoints. Straight line has no endpoints. So this is the line segment. When we extend both sides, to the line segment, so the AB is a line segment. When we extend line segments on both sides, extends this way and this way, both sides. That means from A to B, extends from B to A. When we extend a line segment to both sides, on the both sides, then we have a straight line. So Euclid's first axiom represents straight line. Euclid's second axiom also represents straight line. So here straight line can be obtained by, in the first axiom, straight line can be obtained by passing through 2 points. In the second case, the straight line obtained by extend the line segment on both sides. So in the first case, straight line obtained by a line passing through 2 points. Here in the second axiom, the straight line can be formed as, can be obtained by, when we extend a line segment on both sides, then we obtain a straight line. Here passing through 2, here extends both sides on the line segment. So Euclid's second axiom is, a line is obtained by extends both sides to the line segment. So this is the Euclid's second axiom. Now the Euclid's third axiom. So when a center and a radius, this is the center and this is the radius. When the center and radius is given, then we describe only one circle. We describe a circle with given center and the radius. So this is the Euclid's third axiom. So Euclid's third axiom is, we can describe a circle with given center and radius. So this is the Euclid's third axiom. So the Euclid's first axiom is, we can draw a unique line passing through two distinct points. Euclid's second axiom is, we obtained a straight line to extend both sides to the line segment. Euclid's third axiom is, we can describe a circle with given center and radius. So that is the Euclid's third axiom. And the Euclid's fourth axiom. So this is a right angle triangle. This is also another right angle triangle. So this is a right angle triangle with some measurements. So this is also a right angle triangle with another measurements. So if we take any two right angle triangles, so the angle formed at this vertex may not be equal to this angle. Angle at this vertex may not be equal to angle at this vertex, but an angle formed at this vertex is always equal to an angle formed at this vertex. That means all right angles are equal to each other. So what is the Euclid's fourth axiom? All right angles are equal to one another. So Euclid's fourth axiom is, all the right angles are equal to one another. So this is the Euclid's fourth axiom. And the Euclid's last axiom, Euclid's fifth axiom is, now a line falling on the two lines. So this is a line which falling on this line and this line. So when a line falling on the two lines, and the angles and the interior angles which are on the same side of the line. So interior angles which are on the same side of the line means those two interior angles represents these two or otherwise these two. So clearly this is a less than 90. This is also less than 90. If it is less than 90, if it is acute angle, then clearly this is an obtuse angle. So this is less than 90, then this is greater than 90. Now here I said, the pair of interior angles which are on the same side of the line is always less than two right angles, means they represents these two only. So on that side, if we produced infinitely, surely they meet at a point. When the sum of interior angles which are on the same side of the line less than 290s or less than 180 degrees, in such a case, that side if we produce infinitely, surely they meet at a point. Here the two angles, the sum of these two angles does not less than two right angles, that is greater than two right angles. On that side, if we produce infinitely, they cannot meet. When they meet at a point, when the sum of interior angles on the same side of the line less than two right angles, on that side, if we produce infinitely, they meet at a point, or otherwise they cannot meet, right? So this is the Euclid's fifth axiom. So the Euclid's fifth axiom is that a line falling on two lines, a line falling on two lines, and the interior angles which are on the same side of the line, less than two right angles, that side, if we produce that side infinitely, they meet at a point. So this is the Euclid's fifth axiom. That once again, right. So the construction of geometry, or to construct the geometry, there are a few main stages are there. The first one is undefined words. Second one is defined words. Third one is theorems. Fourth one is axioms. So what are the undefined words in our geometry means? They are point, line, plane and the space. Except these four words, remaining all words are defined words in our geometry. And the next stage is theorem. What is meant by theorem? A theorem means a statement which can be well defined is known as theorem. Actually, every theorem is of the form P if Q. So every theorem has how many parts means every theorem has two parts. And the first part is before, the part of the statement before if, that is P, named as data or hypothesis. Second part of the statement after if, that is Q, named as summary or abstract or conclusion. Now, the various stages in the structure of geometry. So before of this one, we learnt the stages in the construction of geometry. Here we discussed about the stages in the structure of the theorem. The stages in the structure of the theorem means there are 6 stages are there. The first one is general information, second one is figure, third one is data, fourth one is summary, fifth one is construction, sixth one is proof. So in previous papers we have a bit on this concept. So that is, which of the following step may not be required in the proof of all theorems? If any options are given, we choose construction only. So construction not need in every theorem. So it need in some proofs only, but not all proofs. So which of the following step may not be required in the proof of all theorems means any options are given, we choose construction only, right? So that is the third stage to construction of geometry. What is the last stage of the construction of geometry? Axioms. Axiom, right? What is an axiom? Axiom. What is an axiom? So theorem means able to prove. Here not able to prove. But the statement in theorem, the statement is able to prove. In axiom, the statement not able to prove, but the statement always can be treated as true. So, the statement which can be considered as true but not able to prove, such statements are known as axioms. So, our geometry totally depends on Euclid's axioms. In Euclidean geometry, our entire geometry depends on the Euclid axioms. So, how many Euclid axioms are there? 5 Euclid axioms are there. In 5 axioms, what is the first one? That represents about a straight line. What is second axiom? That also represents about a straight line. In the first axiom, straight line can be obtained by passing through 2 points. In the second axiom, straight line can be obtained by extends both sides to the line segment. So, Euclid's first axiom is we can draw a unique line. We can draw a unique line passing through 2 distinct points in the plane. So, that is the Euclid's first axiom. And what is the Euclid's second axiom? When we extend both sides to the line segment, then we obtain a straight line. So, that is the Euclid's second axiom. So, a line is obtained by extends both sides to the line segment. That is Euclid's second axiom. Now, what is Euclid's third axiom? We can describe a circle. We draw a circle. We can describe a circle with any point as the center and given radius. So, Euclid's third axiom is we can describe a circle with given center and radius. That is the Euclid's third axiom. And right. So, what is Euclid's fourth axiom? All right angles are equal to one another. All right angles are equal to one another. Now, the Euclid's last axiom, that if a line falling on any 2 lines, that means the line can be known as transversal line. So, on the same side of the line, on the same side of the transversal, sum of interior angles is always less than 290s or 2 right angles. On that side, if we produce infinitely, surely they meet at a point. So, that is the Euclid's fifth axiom. So, these all are the Euclid's 5 axioms, right? So, the next one,